We are now still on the topic of lists, but we're going to be focusing on linked lists. And I really want to break this down a little bit more. We had a good look at array lists, but with linked lists, I want to break the data structure down and have us actually implement it from scratch ourselves, as we will see. A linked list does have a lot of similarities with an array list, and there are differences as well. We will cover all of that, as you will see shortly. This is a representation of a linked list. The links you can see are there, but we will talk about that in the visual representations as we go through this PowerPoint. So let's take a look at the contents. We're going to learn about what and why, then an overview of linked lists, how it works with some visual representations. There's a few of those. We will then learn about using the linked list class using the built-in Java API. We will then learn about using some of its methods and what's similar with array lists. We will then implement the linked list data structure from scratch. I will have a video set on those. And then we'll talk about array lists versus linked lists, when should you use one over the other, and the differences as we know them. So what and why? Much like an array list, but with some subtle differences as we will discuss. It's another data structure. Pointers, we're going to learn about pointers, objects that point to the next one, or to something. We're going to learn to implement the data structure from scratch, which should be the most interesting part of this section of the course. We will do this step by step as an in-class project together, or by video, depending how you're taking the course. We'll talk about array lists and linked lists, what are the differences, when should I use one over the other, and heads, tails, and nodes, an important part of the linked list data structure. You can view the linked list Oracle docs right here. So how does a linked list work? Let's break this down in English before we take a look at the visual representations. We'll get to the code, but first let's understand the concept and just how linked lists work. So much like an array list, but each node of the linked list does not solely store an object. So think about an array list like when we stored cities. We stored the city as a string object in each index of the array list, right? So this one had London, that one had New York, this one had San Francisco. In an array list, we store objects. In a linked list, we store objects and an additional piece of data. That piece of data is a reference to the next node. We refer to each element in the linked list as a node, and each node will store the object in question and a pointer or a reference to the next node next to it, to the right. This is referred to as a pointer, and that is what makes the link part of the linked list, is that each element or each node inside of the linked list will point to the next, as well as store an object itself. This reference to the next is what creates the linked part of the linked list, like I just said. Nothing points to the first node, because if you imagine the first node, what can point to it if it is the first node? This is known as the head. The last node, kind of similar to this, it always points to a null reference, and that's how you know when you're at the end. When you don't point to anything else, you point to null. This is also known as the tail. So you have the head, the beginning, the tail, the end, and then your links in between, or your nodes. So let's look at some visual representations which really do help us understand how a linked list works, and this will be before we dive into the code. So a common one is the train example or analogy. In the train, each part represents a node, and all parts are connected by a link one to the other. So you can see our first carriage, 1, points by this line to the second, which points to the third, which points to the fourth, and the fourth is just trailing off here, pointing to nothing, meaning fourth is the end because it points to null. Nothing points to the head because nothing comes before it to do so, right? So how can anything point to the head? Because nothing is before the head. And for the tail, like I said, the tail points to nothing, null, meaning we're at the end. So this is the link between the nodes in the linked list. It's important to note that they only go in this direction. They're not coming backwards like this. That would be a full circle, a doubly linked list, which we aren't going to get into too much detail in this course. So we are talking about singly linked lists. And this is another visual representation. It's a very clean and clear diagram. on how we can see each node points to the next, nothing points to the head, and the tail points to null. So we have some integer objects here. 4 points to 6, points to 8, points to 2, points to null, meaning end of the list. Each object or each node, it has a pointer which points to the next one, apart from the head, and of course the tail points to null. This is a singly linked list again because they point in this direction, we're not pointing backwards. Another visual representation, you can see the head pointer. Here we kind of break each node down into two objects. It's the same as a previous example, but you can see how the node is broken down now. We have the information, or the object, and the link. Info, link, null, stop. So that is another one. Here is yet another one, which again is similar to the last, but now we can see the link that we are pointing to. So we're storing 10, and this is pointing to 4900. This is storing 15, pointing to object 5000. This is 5, pointing to 3000. This is 3000, storing 20, which points to null. So the element is in black, and the pointer is in green. And I believe this is our last visual representation. Again, just a pretty clean example of how this works. By now, I don't think I need to repeat myself on the explanation of how this works. Just look at this and try to gain an understanding. We will go to using an example of a linked list using code in just a minute in the next video, and we will do this example. So watch out for that in the next one. But I want to cover some linked lists key methods here before we move on. These ones probably look pretty familiar, and that's because they're shared mostly with the array list. So is get, right? We know get can retrieve an element from the array list at a given index. It can do the same for a linked list. These ones are different in linked lists. We have add first, which adds an element to the head of the list, so we can get a new head. Just like that, we can add last, which will give us a new tail. We can do element, which won't create a new head, but it will retrieve the current without touching it. And then we have pop and push. These are pretty important. We're going to be talking about stacks and queues in a week or so. These are going to come back when we talk about queues, I believe. So pop and push, or stacks and queues actually. So pop and push will remove the front element, the head, and add one will be the new head, and push will create a new first element, which would be the head. So we'll see all of these in action. Then we will talk about implementing our linked lists from scratch, which will probably have us like this, but I'll try to take it nice and slow. Now we're going to dive into a little bit of code with Java's built-in linked list before we do implement our own, so look out for that next.